Hello everyone, welcome to Study Made Easy, a smart learning for a smartphone generation. Now in this video we'll be continuing our discussion on sets. Now in this video I'll be discussing upon types of sets, but before coming on to types of sets, let us discuss some examples in which we'll convert the roster form into the set builder form or the set builder form into the roster form. So let's discuss example number 1. Let me suppose I have a set A and the set is 1, 2, 3, 6, 9, 18, and I have to convert this set into the set builder form. Now if you notice these numbers, notice that each of these number will divide 18 perfectly, right? So the common property among all these numbers is that they all divide the digit 18 perfectly. So we can convert this into set builder form as we'll write x such that x is a positive integer, x is a positive integer and is a divisor of 18, right? So this was the roster form or the tabular form, and we converted the roster form into the set builder form, right? Now again let us take the second example. Let me say we have a set B and the set B is simply 3, minus 3. Now you have to convert the roster form into the set builder form. Now notice that this set, isn't it a solution of, let me write it first, x such that x is an integer, and x square minus 9 is equal to 0. Now notice that these two are the solution of this equation, right? If I have to elaborate it, I'll write x square minus 9 will be equal to 0, and then x square will be equal to 9, so x will come out to be plus minus 3, right? So I can write this as x such that x is an integer and x square minus 9 is equal to 0. Now this is the roster form and its set builder form will be this, right? Now some more interesting examples. Let's take example number 3. Now suppose we have a set builder form and we have to convert it into a roster form. How will we do that? Let me suppose I have x such that x is a letter of the word principal. So we have P, we have R, we have I, N, C, I, P, A, L. You have to convert this into a roster form. Now a roster form can simply be written of this. We can write simply P, R, I, N, C, I, P, A, L. But this is not actually correct. Now why? Because I have already told you in my previous video that in a roster form we don't repeat the elements. So here you can see P and P gets repeated, I and I also gets repeated, so we have to omit these. We have to write these only once. So we'll write it as P R I N C, and then we'll write A, and then we'll write L. So this is the correct answer for this one, right? Now I hope you have understood this. Now let's move ahead and let's talk about the types of sets. So we have types of sets. The first type of set is simply empty set. We have empty set. Now, what do we mean by an empty set? A set which doesn't have or which doesn't contain any element in it is called as an empty set, right? Let me give you an example. Now let me say we have a set A such that X is a, let me say X is a student, let me say X is a student presently studying in both class 9th and 10th. X such that X is a student presently studying in both class 9th and 10th. Now we know that a student can't simultaneously study in both the classes. So obviously A will not contain any element in it. So A is nothing but an empty set, right? It doesn't contain any element, so it is a empty set. And the symbolic representation for an empty set is simply phi. We call it as phi, right? This is a symbolic representation. Now another representation of an empty set is simply write like this. You don't write any element in it, right? So this is what we mean an empty set. Let us move ahead and let's talk about the second thing, and that is we have equal sets. We have equal sets. Now what is an equal set? Now for a set to be equal, all the elements, let me say I have a set A and I have another set B, right? Now in order for the condition that A is equal to B, that means in order to have these both sets equal, all the elements that are present in A should also be present in B, right? That means the number of elements in A should be exactly equal to the number of elements in B, and they should be same elements. Let me say if A is 1, 2, 3, then B should also be equal to 1, 2, 3, so that A will be equal to B. Now each and every element of A should be in B and vice versa. So this is what we mean by equal sets. Now let's talk about finite sets and infinite sets. we have finite sets and we have infinite sets. Right? Now what is a finite set? A finite set, as the name suggests, is that set which contains a finite number of elements. For example, I have a set A and it contains a finite number of elements, let me suppose up to this or up to 10. So these are finite numbers, right? So A can be called as a finite set. That means we can count the number of elements in this set. And finite sets are generally represented in roster form. It is convenient to represent finite sets in roster form. Right? While as what is an infinite set? Now again, as a name suggests, an infinite is a set which contains an infinite number of elements. And the example would go as 1, 2, 3, 4 up to infinity. Right? So since you can't count the number of elements in here, we say it is an infinite set. Now infinite set, it is convenient for us to represent an infinite set in set builder form. We usually represent infinite set in set builder form, right? So if I take this example, its set builder form would be something like that: x such that x is a natural number, right? X such that x is a natural number. See here, it is more easy and more convenient to represent an infinite set in a set builder form. Now I hope you have understood this clearly. We'll be doing some examples in the later videos. I am only discussing theory with you. I'll be discussing numericals in the later videos. I'll see you in the next video. Till then, take care and study smart.